Hello and welcome back to the course on machine learning. In the previous tutorial, we talked about the hierarchical clustering, the intuition behind it and how it works. But at the same time, we didn't quite understand what the whole purpose of HC was and what the benefit of it was. Yes, we went from a huge amount of clusters where every single point or data element was considered a cluster and then to one big cluster. But as a result, now we have one huge cluster. What's the point of all of it? How do we get to the result we want, the actual clustering? So like in k-means, for instance, we would have 2 or 3 clusters. How do we get to that right number of clusters? So this is where the dendrograms come in and they will help us understand everything. So let's get straight into it. So here I've got a chart on the left which contains 6 points. And on the right, I've got another chart. We're going to use this chart to create a dendrogram. Now, I know it might sound a bit confusing at first, especially because we haven't talked about dendrograms, but through creating one, we will learn what they are. So first off, just to make things a bit more legible, I'm going to add the points at the bottom so that they're a bit bigger so we can see them better. And so there they are, the points just listed on the bottom. On the vertical axis, we've got Euclidean distances, and it'll all make sense just now. So we're going to now go through the HC algorithm and slowly create those clusters. So to start off with, every single point is an individual cluster, right? So every single one of these points is an individual cluster. Next, what we're going to do is we're going to find the 2 closest points, which are these 2, and put them into one cluster. So that's our step 2 in our algorithm. So there we go, that's the 2 closest points, and now we're putting them into one cluster. Now, what we want to do on this diagram here, on the dendrogram, is we want to somehow signify that these were indeed the 2 closest points, because the dendrogram is kind of like the memory of the HC algorithm. It's going to remember every single step that we're performing. So there they are, those 2 points, P2 and P3. How do we signify that we've just connected them and that they were the closest? Well, to connect them, we would use like a horizontal line, but then where would we put it? Would we put it at the very bottom? Would we put it a bit higher? What's going to determine the distance, how high we're going to place this line? So this line is actually placed, this height actually has a meaning. This height is the Euclidean distance between them, and it also represents the computed dissimilarity between the 2 points or the 2 clusters. And what that means is the further away 2 points are, so for instance, P2 is that far away from P3, and this could be a variable, for instance, could be the age of a person, right? And this variable could be, for instance, the salary of a person, right? Or this variable could be how long a person has been with the company, and this variable could be the salary of that same person, something like that. So basically, we can see that P2 and P3 they have that distance between them, whereas P2 and P4 have a greater distance between them. And that means that these 2 points, P2 and P3, they have a certain dissimilarity, which is measured by the distance between them. So the distance represents the dissimilarity between the 2 points. And P2 and P4 also have a dissimilarity, and it's greater because you can see that the distance is greater. So let's say if this was age and this was salary, these 2 points, even though they're not identical, they are less dissimilar in terms of age and salary than P2 and P4. And again, these variables are just arbitrary. I'm just calling out arbitrary variables. They could be anything else, and this data set could not be employees, it could be machines, it could be certain observations from nature, and pretty much anything. The point here is that the further away 2 points are, the more dissimilar they are, and that is being measured or captured in our dendrogram by the height of this bar, how high we're setting it. And then the bar itself just shows us that we connected P2 and P3. All right, so that's our first step in the dendrogram. Next, we're going to move on, and we're going to proceed to the next step in our HC algorithm. We're going to perform step 3. So we're going to find the next 2 closest clusters and connect them. So here we've got each point out of these 4 is a cluster, and then we've got this cluster. Now we need to find the 2 closest out of all of them. And let's say, or from what we see, these 2 are the closest. So let's outline them. There we are. And so now they form their own cluster. Now we want to point that out in the dendrogram as well. So again, we're going to place this horizontal line. Again, how high do we place it? Do we place it higher or lower than this line? Well, we agreed that this vertical axis represents the Euclidean distance, and Euclidean distance represents the dissimilarity between two of our observations. So here we can see that P5 and P6, they're actually further apart than P2 and P3. And that is, of course, natural, because if P5 and P6 were closer, then in the previous step, we wouldn't have put P2 and P3 in one cluster. We would have put P5 and P6 in one cluster. Remember, we're always looking for the closest, and then we're moving on to the next step. So P2 and P3 were the closest, and that's why this distance is such. P5 and P6 are further apart from each other than P2 and P3, so the distance has to be greater. And that's why we're going to show that on the dendrogram. You can see that this bar is set higher. All right. And the next step is to, again, repeat step 3. So we're going to look among all of these clusters, which are the closest. So there we go. So this one was the closest. So I'm going to go back here. This cluster is closer to this cluster than to any other cluster. And pretty much out of all the distances between the clusters, this is the lowest. Again, a lot here is determined by how you measure distances. We can see that the distance between P4 and this cluster is quite close to this distance, but we're going to say that this distance is the lowest. All right, so what we do next is we combine these clusters into one cluster. Let's do that. There it is. So now we have one cluster. Now we need to represent that somehow here. So what we just did is we took this cluster that we have, P2 and P3, connected it with P1. So again, we're going to draw a line, and we're going to draw our vertical lines here again. And once again, the distance here from P1 to the top over here represents the dissimilarity between that cluster that we had and the point that we connected it to. All right, so now let's find what's the next step. Next step, again, is step 3, and we're going to look out of 1, 2, 3 clusters that we have, which are the closest. Well, obviously it's P4, and it's the closest to these. Again, there it is. We're expanding that cluster. Now we're going to represent on the dendrogram. As you can see, the line is about the same height as this previous line, because the distance between P1 and this cluster was about the same as the distance between P4 and P5 and P6. Maybe this one was a bit greater. Sometimes it's hard to tell, and that's why we have algorithms. That's why machines do it for us. One of the reasons. That's what our dendrogram looks so far, and our final step is to combine these two remaining clusters, because by default they are going to be the closest since there are no other clusters. So we're going to combine them and represent that on our dendrogram. So here the line is very high because the distance or the dissimilarity was very high between these two clusters. And there we go. So that is how we construct our dendrogram. Slowly from the bottom up, it's being constructed, and at the end we've got that one cluster. So all of this is one cluster. And that is what I mean when I say that the dendrogram contains the memory of the hierarchical clustering algorithm. So you can, just by looking at the dendrogram, understand in which order these clusters were formed. And here I've got an example. So this is the actual example generated by computer, generated by an algorithm, showing us the hierarchical clustering. So we've got the points here, and we've got the dendrogram over here. So this is what it actually looks like. All right, so now we know how dendrograms are constructed. In the next tutorial, we will learn how to use them to enhance or actually execute our hierarchical clustering algorithm. So there we go. Hope you enjoyed today's tutorial. I look forward to seeing you next time. And until then, enjoy machine learning.